This week on Silicon Valley Squares, Terry McClure, Sam, Mad Scientist Marasini, Ryman Matt BURR, Matt Kixmuller, Charlie Giancarlo, Melissa Monroe, James Gallegos, the Pure Go Gorilla, and your center square, Scott Baker.
Welcome to Silicon Valley Squares. I'm your host, Kevin Delane, and everybody is joining you from the comforts of their own homes. Now, let's meet our contestants. Mr. X, tell us a little about yourself.
Sure. Hi, everybody. I'm Calvin Nee. I consider myself a product marketing extraordinaire. I enjoy playing guitar, tinkering with my vintage bikes, selling Girl Scout cookies, and doing my hair.
Well, your hair looks perfectly coiffed today.
Thanks, Katie.
Miss Hex, why don't you tell us a little about yourself?
Hi, my name is Michelle Salta. I'm a program manager, and in my spare time, I love to cook, read, and do yoga and jujitsu.
Well, I'll make sure I don't get in a fight with you.
Yeah, that's a good idea.
Okay, in case you missed an important part of your childhood, here's how the game is played. To win, you need 3 pure squares in a row, either horizontally, vertically, or diagonally. You pick a celebrity, I ask the question, they answer. Our contestants have to decide whether the celebrity answers are legitimate or they're just making them up. Each square gets you $100. You win the game, you get an extra $200. Ready? Michelle, you won the toss. Who would you like to start with?
I think I'm going to go with Scott Baker.
All right, Scott, the first question to you. What is the new native file capability on FlashArray? Oh. Scott, you're on mute. You're on mute. We can't hear you.
Good call, meatball. This is your culinary gangster here. Sorry about that, folks. You know me. I should be in the kitchen, not on this crazy video conferencing thing. Anyway, what we've done is we've integrated CompuVert technology natively into Purity. Now, our customers can use SMB and NFS on the FlashArray directly, and even from the same pool as their SAM. Now that means they get to take advantage of global data reduction for both block and file. Boom! Welcome to Data Town, baby. Full throttle.
I think I'll agree.
Let's go to the video and check.
Hello, my name is Jonathan Carnes, and this is an introduction to FlashArray file services. In this introduction, we will cover the array dashboard integration, file system creation, managed directory creation, using export policies, and snapshot policy management. First, let's look at the array dashboard integration. FlashArray file service was designed to be fully integrated into the FlashArray GUI. Here on the dashboard, we can see array-wide metrics. We can also select block volume performance metrics, file system performance metrics, or see both metrics side by side. This allows you to quickly see the performance of the array and the workload live. Next, let's look at file system creation. Pure Storage has removed all the complexity of dealing with underlying block volumes or file pools. Now creating a file system is as easy as clicking a single plus button underneath the Storage and File System tab. Once you've clicked the plus button, a pop-up will pop up. You'll enter the name of your file system and click Create. Once your file systems are created, you can look at the details by clicking on the file system's name. And in here, you can see how many different directories you have created.
Next, let's go over managed directory creation. Managed directories are folders within file systems that are created by storage administrators. These folders act as anchor points to allow storage administrators to apply various configurations such as export, shares, and snapshots. Creating managed directories is just as easy as creating file systems. You simply go to this directory section of the tab. You click the plus button next to the directories to create a new directory. Select your file system, give it a management name, give it a directory name for the folder, and click Create. By accessing Directory Details tab, you can access management to directory exports, directory snapshots, and also see information about your directory. Next, let's go over using export policies. Export policies are templates of configurations for shares and exports that you want to apply to your managed directories, allowing you to share data out to your end users. To create new export policies, we can navigate to the Storage and Policies tab, and then in the Export Policies, we can click plus. Here we can choose two different types, NFS or SMB. Let's go ahead and create an NFS policy. We'll call it Demo NFS and click Create. We can go back and we can create another policy. We'll choose SMB this time, and we'll call it Demo SMB. Now that we have some policies created, we can open up the details page of the policy by clicking on its name. Here we're able to add configuration rules and attach this to some managed directories. Let's go ahead and create our first rule by clicking on the plus button here. This will give us a pop-up that has a read-write access list that we can set for our NFS export. We can also select to have root squash or no root squash. We'll go ahead and click no root squash and click add to add our rule. Now that we have our first rule, we can go ahead and attach this to one of our directories within our file system. So we'll go ahead and click on the plus there, select the directory we would like to attach to, and then we can go ahead and give this an export name that the clients will see. Let's repeat this process with our SMB policy. We'll go ahead and add our first rule. Here again, we have our read-write access list. We can select anonymous access to be enabled or disabled, and SMB encryption to be forced or optional. Let's go ahead and leave it as default, and we'll click add to add our first rule. Again, we can go ahead and attach this to one or more directories. We can go to the same directory we have NFS off. In this case, we'll do the same thing. We'll give a share name to be presented and hit create. Clients now have access to our demo directory by SMB and NFS. Lastly, let's look at snapshot policy management. Snapshot policies allow you to set up schedules and retention periods for snapshots of managed directories. By going to Protection and Policies and clicking on the plus button, we're able to add a new policy for snapshots. We can simply enter our name and click Create. Once you have a snapshot policy created, you can access its details by clicking on its name. Here we'll need to add some rules to our snapshot policy. Let's go ahead and add a rule for our daily snapshot. We'll take a snapshot every day at 5 p.m. We'll go ahead and keep those snapshots for 7 days. We'll give it a client name of daily. This is what the clients will see when they access the .snapshot directory. Click Add, now we'll add our rule. We can also add multiple rules. So let's go ahead and add another for a weekly snapshot. We'll take this every week. We'll keep it for 4 weeks. And we'll call the client name weekly. Again, we'll click Add. Now we have 2 rules. Let's go ahead and attach this to a couple directories. Simply click on the 3 dots. We select the directories we'd like to attach to. We click Add.
You are correct. Hex gets the square. Okay, Calvin, you're up.
I'm going to pick BURR.
What up, data nerds?
Okay, Mr. Burr, here's the question. Are there any updates to quality of service on FlashArray?
The MSPs won't let me be. You see, what they want is consistency. QoS will deliver that, I guarantee. Per your subscription, that'll come for free. Share and IOPS will flow without the dips. Resource allocation not having a trip. Buckle up. This is about to get heavy. Quality of service in 6.0. Yo, it's straight up ready.
Wow, that was awesome.
Was that an answer?
Oh, Charlie, of course it is. He said quality of service is being added natively to Purity 6.0. Customers can use it now to achieve their desired performance and limits.
Really?
100% correct. I think I'll agree.
Well, let's go to the video.
Hi, my name is Ben Casey. I'm in technical marketing at Pure Storage. And I'm going to show you how simple configuring quality of service is on the FlashArray. So let's look at what volumes we have. Click on Storage. Click on Volumes. You can see my volumes listed here, Charlie, Dennis, and Mac. Charlie is almost always the one consuming all the resources. So we'll click this menu over here, and we will click on Configure QoS. And you see we have options. We have a bandwidth limit, kilobytes, megabytes, or gigabytes is how we can define that limit. And we have an IOPS limit, You can configure it by the thousands or the millions. Well, we're consuming the entire connection bandwidth for that fiber channel port, and that's about 800 megabytes a second. That's a little much. So I want to lower it to 200 megabytes a second. I'll click Save, click on the dashboard, and look at that. We were saturating that fiber channel link here at about 800 megabytes a second, and now it's precisely at 200 megabytes per second, just as I asked it to. Go back over here to volumes. We can click on Configure QoS again, and maybe I want to give it a little bit more juice, so I'll say 400 megabytes. Click on the dashboard, and you can see those changes are instantly implemented. We do this by manipulating the queue depth. Maybe we want to limit it by IOPS. We'll click on storage, and we'll go back through this routine again. Click the menu, click Configure QoS. All right, it's set to kilo or 1,000, so we'll say 2. Click Save. Head over to the dashboard. You can see that we have an immediate change in IOPS, and it is effectively limited to 2,000 IOPS. Of course, it impacts our bandwidth, and it's come down slightly to about 500 megabytes a second. That's as simple as it can be. Thanks very much. That's all there is to it. And that's all there should ever be to it. This was QoS on the FlashArray.
Well done, Calvin. Let's throw an X on the board. Now, Michelle, what's your pick?
I'm going to go with TERRI.
Hello, TERRI.
Hi, Kevin. Great to be here.
Great to have you here, TERRI. Now, let's get down to business. Here's your question. What's new with the Pro Edition of Pure's VMware Analytics Pro?
Absolutely nothing. They just added the Pro on it to make it sound professional.
That doesn't sound right to me. I'm going to disagree.
Let's look at the demo and see.
Hi, this is Stan Yanitsky from Pure Storage, and I'm here today to talk to you about the VM Analytics product in Pure One. The goal of this product is to provide a visual representation of your VMware environment in order to allow you to drill down into problems and figure out where the issues are originating much faster than you've been able to in the past. But before we get into the actual product, let's take a look at how we collect the data. In the top left, you can see the collector configuration. All the collector is a Docker container that allows you to pull metrics from vCenter via API. So that means there's no plugins that you need to install in your environment. There are two ways to deploy it. One is on the array, and the other is off array, or on a VM in your environment. For the on-array collector, support will drive the whole process from installing Purity Run to installing the collector, and they'll help you get that set up. For the off-array collector, if you want to run it in your environment, you can set that up yourself. So in order to do that, you just create a new collector, you can give it a name. Once you do that, you can click this button to view the installation script. It's a simple one-line install that you can copy-paste into your VM, and it will download the collector from Pure One, it will verify the checksum, and it'll install it for you. You can, of course, do this yourself if you so wish. The instructions will be available on our support site. Once you've got that installed, because we're only making API calls, we just need a read-only user for your vCenter environment. You can use VMware's RBAC in order to restrict what that user can see in terms of data centers or clusters or even VMs. And if that user can't see it, then we won't be able to get that information, so that data will not be shown in Pure One. Okay, now let's get to the core of the product. Here you can see the topology, where we start at the disk, to the VM, go to the host, data store, to the volume, and to the array. So the very first thing you can do is you can click on any of these, and it will highlight what's connected to each one of those nodes. so you can see exactly which volume this particular VM is on or what array it's on. You can also select it from the other direction in order to see which VMs are on this particular array. Another thing you can do is you can change the metric that shows up on the node. Right now we have write latency selected, but we can choose IOPS, bandwidth, CPU, or memory. Let's take a look at IOPS. What this will do is it'll allow you to sort on a different metric. So if we're looking at IOPS here, you can see that this VM is doing the most IOPS, or if we sort the other way, we can see VMs that are paused, as denoted by the dashes, or have done no IOPS in the last 24 hours, as you can see the time window here. You can see up to a week's worth of data. Let's go back to the latency, as that's our primary use case that we're trying to solve. If we sort back the other way and see this VM has a relatively high latency. So one thing we could do is we can click to highlight, and then we'll filter down to that particular VM. This will help get the rest of the VMs out of the way, and in order to help focus the screen on the particular issue that you're trying to solve. So the first thing you see here is that the array and the volume both have fairly low latency. So we know that the problem doesn't exist in the array. The data store and the host also both have low latency. So we know we don't need to do any troubleshooting at those levels. So at this point, what we want to do is start looking at the guest and above in terms of latency troubleshooting. There are a lot of other options that you can kind of see, and a lot more information that you can glean in terms of where that latency is originating. We won't be going over all of these different scenarios in this demo, but we will have material available to help you identify where that problem is originating. The next thing we want to do is we can hit the checkbox on any of these nodes in order to plot them in the graphs here. So you can see the three graphs along with CPU and memory. If you want to zoom in on a particular spike, like this over here, you can click and drag to zoom in, and you can see the time range has changed to this 2-hour period. Now that we've isolated this spike, what we can do is clear the filters that we applied, and now we're looking back at the whole environment at that same time window in order to see if anything else happened in the environment at that particular point in time. So what we did was we started wide, identified the VM that was the problem, figured out when exactly that problem happened, and then zoomed back out in order to look at the rest of the environment to hopefully understand the impact of that particular time period. There's a couple other things that I want to show as well. One is searching here. You can search or filter on any VM, host, data store, volume, array, or disk name. All you need to do is just type in what you're looking for, and it'll automatically start filtering everything in your environment. And finally, you can collapse the nodes in order to help identify some groupings. So if you collapse the column, it will group it by the column to the right. So I collapsed the VMs column, and now it's grouped it by all the VMs attached to the host. So this particular host has 26 VMs, and so on and so forth. In the top right here, you could also collapse all, which shows you the aggregated metrics for everything here. We can select any one of these nodes to select everything and expand, and now we've got everything selected as you see here. You can see at the bottom, the average latency for everything that's selected is less than 1 millisecond. So this cluster is doing pretty well. If you choose a different metric, say total bandwidth, the aggregation changes to sum, and it shows you the total sum of the bandwidth of everything that's selected. So if we remove, for example, this array from the selection, you'll see that the numbers will change. This gives a pretty good overview of the VM Analytics product. This isn't necessarily everything that you can do in it, and so we recommend that you check it out, play around with it, because there's a lot of different tools and a lot of different ways you can use this product in order to help identify issues in your environment and hopefully solve them a lot faster than you've been able to in the past. Thanks for watching, and I hope you enjoy the product.
You are correct, Michelle. TERRI's answer is 100% wrong. Clearly, there are tons, loads, a massive amount of new features in VM Analytics Pro. Calvin?
I'll take Melissa for the block.
Hello? Is anyone going to call on me over here? I do have other things to do.
In due time, Chuck, in due time.
It's Charlie.
Sorry about that, Charles.
You know I'm your boss, right?
All right, Melissa, here's a question for you. Name 3 types of replication offered by FlashArray.
I have been prepared for this question. It has a...
Oh. Ooh, she froze. Melissa?
continuous mode between
I think you froze.
hosted in 2 different storage systems.
Melissa, your video froze. Can we get your answer again?
Yeah. Sorry about that, guys. FlashArray has storage replication in asynchronous, synchronous, and continuous mode between volumes hosted in 2 separate storage systems.
I'd be insane if I didn't agree with that. Agree.
Agree. Let's find out.
Hey everyone, let's take a look at the ActiveDR simple continuous replication feature from Pure Storage. So what is ActiveDR anyway? Well, it's all about business resiliency and giving you the ability to streamline your disaster recovery processes, to readily adapt to changes in production and have those get reflected in your DR environment, and to fail over quickly and immediately respond to disasters with just a click of a button. All of this at nearly any distance, with no additional infrastructure, and with integration with our snapshots, protection groups, and volumes. It's based on kind of the traditional model where site 1 is a production site and site 2 is your DR site, and we can connect them virtually over any distance. It simplifies the DR workflow, it adapts on the fly to changes that you make in production, and it doesn't require any additional infrastructure. All of this translates into superior data protection, a near zero RPO for the minimum amount of data loss during a DR, a low RTO, quick failover, all of it delivered on a single platform, FlashArray. We've made deploying ActiveDR extremely simple, really just 4 steps. Our demonstration environment consists of 2 sites, one in London, one in Prague, and the distance between those 2 is approximately 600 miles. We have a Windows 2016 server attached to a FlashArray at each of the sites. Those 2 FlashArrays are connected with 10 gigabit Ethernet for the replication network. And then configured on each of the arrays are pods. On the production site London, we'll have prod pod 1 with 2 volumes in it. And then you'll see throughout the course of the demo, when we create the replica link to Prague and our DR site, that we'll get a second DR pod with the same volumes in them. So we'll have a demo volume and an IOM volume. So if I go to pods and select prod pod 1, I can use that pod as my source pod. So into that pod, I want to move 2 volumes that correspond with the applications that I have running in production, Iometer and this production data application. So I'm going to use the move in function and move those volumes into prod pod 1. And then from there with ActiveDR, we simply create a link between that pod and then one in another FlashArray, TME FA12. So here we're connecting TME FA12, we're selecting async replication, and then we're putting in our connection key so that we can let the 2 arrays communicate with one another. And then what's also nice here is we're able to, even if there isn't a pod ready at the DR site, we can create one. So here we're just going to create a pod named DR pod. And as simple as that, we've got the 2 arrays connected, replicating, and initially things start off by baselining. Obviously, the target doesn't yet have all the data, so we need to baseline it to get it set up. From there, once baselining completes, we move to replicating mode. So you'll see here we've transitioned on the right to replicating mode. And then as soon as the GUI on the left refreshes, now we're replicating and we're getting an extremely low, if you look at the lag, it says 1 second RPO. And at the target site, the volumes are available. Now I can pre-connect hosts. So here at my DR site, I'm going to use the DR demo win host, and I'm going to connect the 2 volumes that are in that DR pod ahead of time, again, while I'm replicating with no impact to my RPO. My RPO is still 1 second if you look at on the left there. And now if I look at the serial numbers, I see I've got the 2 volumes there. And if I rescan my Windows host at my DR site, the 2 volumes show up, and I can actually take a look at the content if I'd like. So if I wanted to do a test failover, the way that we do that is we use the promote command. So promote means we're going to make the volumes in that DR pod read-write enabled. So as soon as it transitions from promoting to promoted, complete, it should take a second, I can now go and start up my applications at my DR site. So in this case, my example app is Iometer. And then I also have a file a batch file that's going to generate that same sort of production data output that you see, but now labeled DR data. So now I'm running my DR tests. When those tests end, I'm done testing, all I need to do is demote the pod. And by demoting it, I'll discard those changes and return to normal replication mode. For a real DR situation, the steps are identical to the test failover scenario. So here, we're going to simulate power loss at the production site. So that's represented by the gray area there. And our response, just like it was in test, is to promote our DR pod. Now the promote process is taking the changes that have arrived while the pod was demoted and applying them and bringing that pod up to the latest point in time so that you have the least amount of data loss associated with the failover. So now once the pod is promoted, as shown on the screen, we can come down and we can start up our DR application. So before we had an application that writes the prefix DR data to the data that's being written to a file. And then we'll also show that we can start up Iometer. So here Iometer going against that E volume also can be started. So at this point, we're relatively in a matter of seconds, we're back online, we're running applications at our DR site, and our business is back. Now, when power is restored to the production site, if we want to reprotect or reverse from our DR site back to production, all we'll do is demote that production pod. So you'll see the arrow is going to transition, and now it shows the replication going from the DR pod to the prod pod. And once this baselining process completes, we'll be back in kind of the reverse situation that we started with. We have production running at the DR site, and now production is going to be where the data is landing or being replicated to. And now if we take a look at our log file, we can see that the DR data is in fact arriving at the former production site, and now we have a nice reprotected application running at DR. So that's really the simplicity and ease of using ActiveDR. And again, it's all about simple continuous replication, and it's part of a family of features built into FlashArray. ActiveDR provides continuous data replication, near zero RPO, and very low RTO to simplify your disaster recovery process. If you have any questions about ActiveDR or Pure Storage products in general, please visit purestorage.com. Thank you.
That's right. X takes a square. And as a reminder, all replication options are effortless. They require no additional hardware. They're inclusive in our Evergreen subscription. And so there are no add-on charges after your purchase.
Exactly. It's the best.
Seems like she's frozen again, but that doesn't really matter. Let's move on. Michelle?
Sam for the block.
Sam, what have you been baking up?
Baking up? I've been baking all sorts of things. I've been baking bread. I've been baking cupcakes. I've been baking birthday cakes. But maybe most important and most interesting, I've been baking Direct Flash.
Looks delicious. Question: what are some of the new VMware integration options with the FlashArray family?
What an incredibly easy question. Our engineers have spent countless hours working on exactly that VMware integration. So, everyone, say it with me. vSphere 7 with NVMe over Fabrics, VCF, VMware Cloud Foundations, iSCSI, Fiber Channel, vVols, SRM with vVols, SRM with ActiveDR. It is a piece of cake.
Wow, that was quick. Now, Michelle, you think Sam's trying to steamroll you, or is his answer right on the money?
It was quick, but I guess it's right. I'll agree.
All right, let's check the video.
In this demonstration, you'll be seeing how to use Site Recovery Manager with Pure Storage FlashArray virtual volumes. I have a set of virtual machines here with vVol storage policies sitting on a vVol data store. So let's go into Site Recovery Manager. Site Recovery Manager 8.3 released the support for virtual volumes leveraging array-based replication for failover, greatly simplifying the configuration, setup, and failover and protection of virtual machines. I'll create a new SRM protection group, give it a name and a description, and choose the vCenters I would like to protect. Then I will choose virtual volumes, and a FlashArray is listed as a vVol replication source. I will choose that FlashArray and a consistency group, also known as a replication group, that is listed under that particular FlashArray. It has all the virtual machines assigned under that particular vVol replication policy. Create a new recovery plan and commit. A recovery plan fails over a set of virtual machines leveraging array-based replication, in this case with vVols. Now it's time to test that recovery plan. One of the main SRM features is not only recovering of virtual machines, but also testing that recovery process. A test recovery is built in to the vVol integration with array-based replication. SRM now has the ability to coordinate that process. An SRM test failover will synchronize the storage before bringing up a test environment of those virtual machines on the target site. The test is now synchronizing the storage and preparing to bring up the virtual machines in the target vCenter environment. The virtual machines are being updated, and the placeholder virtual machines in the secondary vCenter are being replaced. Under the vVol data store on that target vCenter, the virtual machines will begin to be registered and power on according to the recovery plan. The SRM test failover is now complete. In this demonstration, we'll be showing using vSphere 7.0 and the newly supported feature from VMware for NVMe over Fabrics with Rocky v2 on the FlashArray. We currently have our RDMA-capable NICs presented to the ESX environment. Now let's create a new NVMe namespace, aka volume. I'll give the volume a name, and I'll size it with 32 terabytes, showing it is extremely simple to provision storage on the FlashArray, whether it's traditional SCSI or NVMe over Fabrics. I will now find my host group that represents that VMware cluster and connect that newly created volume or NVMe namespace that I created. It is now connected and provisioned to the VMware environment. You can see it immediately appears under the NVMe listing under the NVMe adapter on that ESX host. I can right-click, go to New Data Store, and now I can format that NVMe namespace or volume that ESX now sees with VMFS. Choose the object, choose the latest version of VMFS, and complete the wizard. In VMware Cloud Foundation 3.9, VMware added support to provision principal storage as VMFS on Fiber Channel. In SCDC Manager, the tool to manage your VMware Cloud environment, I'm going to prepare a couple hosts for inclusion in a new workload domain that will be leveraging VMFS on Fiber Channel. You can see the selection in SCDC Manager on the screen. I'll add this host and then add the rest. I can now deploy a new workload domain with those hosts by choosing VMFS on Fiber Channel on Pure Storage as the target option for principal storage with VCF. I'll add those hosts. Choose the networking information so an NSX can be deployed and complete the wizard. This will then go on to proceed to provision the VCF workload domain, leveraging those hosts and VMFS on Fiber Channel via the FlashArray. In this demonstration, we'll be leveraging VMware Cloud Foundation to provision supplemental storage leveraging virtual volumes on iSCSI. The first step is use the FlashArray vSphere plugin to register the FlashArray VOS providers that allows vCenter to communicate with the FlashArray vVol implementation. The storage providers are now registered with that particular vCenter, aka VCF workload domain. The next step is to configure iSCSI on my host. Using the vSphere plugin for the FlashArray, we'll choose the target array and my cluster, and this will configure iSCSI on both the FlashArray and that VMware cluster to allow connectivity. Next, we want to mount the vVol data store. A vVol data store is a capacity limit from the FlashArray that says how much someone can provision to that workload domain. Using the vSphere plugin, this process is entirely automated directly within vSphere. Give the data store a name, choose the compute, choose the FlashArray, the one I configured earlier, and finish the wizard. I can now provision vVol-based virtual machines on my VMware Cloud Foundation workload domain.
You are correct. Now let's put a little hexagon up there to block. This game is sure tight. Calvin?
I'll take the Go Gorilla.
Oh, hey guys. Sorry, I haven't had my pump up protein bar for the day. Woo!
No problem. What do SQL Server Management Studio extension, Windows Admin Center, and SCOM Manager all have in common?
Oh, funny you should ask, KD. Those are things I wait till at least the third date to bring up. But seriously, shout outs to my friends out in Redmond. Those are Pure and Microsoft's latest integrations.
I'll agree.
Let's check the video.
Pure Storage extension for SQL Server Management Studio can be configured with the Pure Storage tab at the top, or by right-clicking the database and clicking Pure Storage. In this case, this is a new database and there's no config, so we're going to click New, type in a friendly config name, select the server, in this case it's the server that we've installed SSMS, select database 1, the FlashArray, and save. Now that we've saved a full copy for this database, that configuration can be used subsequently in SQL Server Management Studio or via PowerShell. So now if we go back into one that is already configured, you can see the PowerShell. It's the commandlet and the config name, really simple. We'll go ahead and click back up here. A few seconds later, we'll create a VSS application consistent snapshot of database 1 on the Pure FlashArray. The next thing that we're going to do is show it off here in PowerShell. So let's execute this. Very similar, and this is how most folks are going to deploy backup is complete. Now we're going to look at the recent jobs, and the context here is it's only showing the jobs for that database. There are more jobs. You could look at all the jobs under Pure Storage at the top. If we were to right-click Split DB, which happens to be part of an availability group, that would also work. Here we're mounting it to the O drive on the other server. It could also be mounted locally. Now let's kick off a backup of Split DB. This happens to be the primary. You could also initiate the backup from a secondary copy of the database. This is going to work just fine, whether it is the primary or not. Now that we're in the split DB context here, we're going to take that snapshot that we just took and mount it. Now in this case I called it split because the database files and the log are on different LUNs. So here you could type in the name of a mount point, for instance. If you click on the drop down arrow, it lets you check available drive letters, and we're checking for available. Now that we've selected 2, the others gray out. It won't let you select more, and we check if you select less. So since the source had 2, now that we've mounted it successfully on T and U, let's look. Yep, there on the T drive, there on the U drive. It is mounted on this server. Of course, it could be mounted on any server. The next thing that we're going to do is do a restore. So let's look at the history for database 1. Let's grab that most recent snapshot. We're going to restore it. It could be done in no recovery mode, which means if you wanted to pull additional files, and you see there that the PowerShell is very simple. So now that we've restored database 1, that's a VSS application consistent restore. Next thing I want to show off is how you can create a computer credential. Here we're creating one for server 1. After we create this credential, we'll create the credential for a new FlashArray. You may have multiple FlashArrays. So in that case, we click the new icon for creating it for the FlashArray. We'll type in the FlashArray's IP and credentials and create that. One of the things you'll notice here is we have a checkbox for RDM. This is in the case of virtual machines running on ESX, where the SQL databases are on raw device mapped. So here I have a failover cluster instance running on 2 VMs, and these disks are all raw device mapped disks. In order to deploy on SQL, you need these disks added to the role. And then you also need to add on the SQL Server resource. You need to add the disks here as dependencies, or else you will not be able to place user databases on them. So now let's look at the configuration for this server. We have FCIDB, and if we look at FCIDB, you can see that we've checked RDM, we've added vCenter, and then you'd need to put a VM name here. And this is the VM that you would restore to. So you'd want the SQL service online on that VM before hitting restore. Thanks. After installing the latest 1910 build of the Windows Admin Center, we're going to click on Settings Extensions and search for Pure. You're going to see the GA version of Pure's FlashArray extension. We'll install it, and then we will log into the FlashArray Manager. We don't have an array yet here, so let's add one. We're going to type in the IP and credentials for our FlashArray. This FlashArray happens to be participating in an active cluster. Once we log in, we can click on the hosts and look at what hosts are there. Create new hosts and host groups on your FlashArray. In this case, we're going to look under the Q-Hyper-V host group and see C4-17, which is the server that we're logged into. Look at the 2 WWN ports for the fiber channel and adapter inside the server. You can disconnect from the host group, from the FlashArray, edit it, destroy it, create a new host or host group. If you click on initiators here, you're only going to see, and in this case you see one server, servers that have been added to Windows Admin Center. Here you can see that we're connected via fiber channel, and we do a scan on best practices. And by looking at the best practices, we can see that in this case, our MPIO policy is not set to our recommendation, and you can fix it right here. Next, we can look and see if there are any protection groups. We can create one, we can manage them. In this case, we just have a couple. Let's look at the bottom one. You can see what members of the protection group are, where the target is, and what snapshots are available. When we click on volumes, we can look at all of the volumes on the FlashArray. We can search for a volume. Let's create a new one. So in this case, we'll create a new WAC test volume. We'll make it 99 gigs and attach it to the server, and then look at it in Disk Manager, maybe format it. In this case, if you type it into the search there, you see it, 99 gigs, it's there. Snapshot creation, instantaneous, right? If you don't need the snapshot anymore, you can remove it. All this can be called from our PowerShell SDK as well. We're not connected, so let's connect it to our host, which is 417. So let's look for that. And if we wanted to connect it to a host group, we could do that as well. In this case, I'm just showing off host, or else you could click on host group above and then select. So now that we've connected it, let's look in disk management. The last disk here will be the most recent one connected, and look at it's 99 gigabytes. So we'll online it, initialize it, format it, and we'll have a disk. And then let's jump to the FlashArray web management interface directly from Windows Admin Center. So there we go. We now have a G drive, 99 gigs, and by selecting the bottom there, we're connecting to the FlashArray's virtual management IP. And here we are. And let's find that LUN that we just created, right? The WAC test LUN. We'll find our server, our host, and then there at the top, you see the only shared false because it's connected direct. Thank you.
Wow, another correct answer. This game is really getting intense. Michelle, time to choose your destiny.
I think I'm gonna go with James.
Okay, that's it for me. I'm done. See you later.
Well, looks like we lost Charlie. No worries at all. We weren't going to use that square anyway. James, you're up.
Hey, Tommy. I'm happy to be here, man. I'm coming at you live from the righteous state of Utah.
It's Kevin, by the way. What platform brings together Pure's container storage and cloud-native data management for Kasten?
Cloud. Yeah, but anyway, so seriously though, I have a dog named Indy right here. And Indy's a canine, so it's the canine platform.
Oh, that dog's adorable, but I really think it's K10, so I'm going to disagree.
Let's go to the video and check.
Online volume demonstration. Create a volume of 10 gig in size, connect it to an Nginx pod. We're now going to patch that volume to make it 20 gig. The persistent volume immediately becomes 20, so does the FlashArray. The PVC doesn't until we restart the pod. You can see that from the Kubernetes output. It needs to do that. So we'll restart the pod, and the persistent volume claim will then change to 20 gig. Snapshotting and cloning, we're going to create a persistent volume, which is going to be seen on the FlashArray, 10 gig in size. We're now going to snapshot that and look at the snapshot metadata. We'll see that the UID matches the volume snapshot. We're now going to convert the snapshot to a clone. You can see that has picked up the original source. Volume import, we have an existing volume on the FlashArray, which we are now going to convert into a persistent volume and a persistent volume claim as far as Kubernetes is now concerned, and mount it to a pod.
You got it, Michelle. Throw up another hex. One square away. But Calvin, you can take it all away. I assume you'll take...
Kicks. I'll take kicks, Kevin.
All right, batter up, Kicks. Here's your question. The last one. After 5 years, how much return on investment can someone expect after implementing a FlashStack solution from Pure and Cisco?
5 years?
Yep.
FlashStack?
Uh-huh.
431.
Excuse me, can you repeat that?
431. I've already answered that.
431 what?
431% ROI after 5 years with FlashStack.
Okay, Calvin?
You know, that seems too high. I'm going to disagree.
Let's go to the video.
Welcome to the Cisco Intersite demo of the Pure Storage FlashArray integration. We've created widgets to provide an overview of storage utilization. We can drill into array volume and provide inventory details. The general overview includes the array model, purity version, and a summary of overall usage of the array. As part of the inventory, FlashArray object model has been exposed into Intersite to provide details including host, host group, volumes and snapshots, and the protection groups. Hardware is also available, including controllers, drives, and the front-end ports that are connected to the array. Cisco Intersight also includes an orchestration engine with tasks and workflows that have been created to help admins complete common management tasks via automation. In this example workflow, we're creating a VMFS data store. To do this, we actually go through the configuration and provide unique details to the environment to really describe the changes that have been made as part of the workflow. This can include the workflow instance name, the storage device that's being utilized, the volume name, the size of the volume, the object model components from the FlashArray that the volume is being connected to, and then also details around the hypervisor environment, the data center, the cluster, and then finally the data store name and the version of VMFS we're going to format the data store with. Once all the unique details are completed, we can execute the workflow. And as you can see here, we have the ability to review the workflow being executed and the details that are required to complete the configuration. Once the volume's been created, we can then go into the FlashArray and actually see the volume that's been created as part of the workflow. And that's the end of this demonstration. Thank you. This is the FlashStack Smart Config deployment tool demo. Smart Config is packaged as a virtual appliance and deployed on an isolated network. It provides a graphical user interface which is accessed via our browser. There are 4 main steps to complete a deployment using Smart Config. Step 1 is discovery and relies on an inbuilt DHCP server. Once configured, this is used to dynamically discover all the Cisco and Pure Storage devices that make up a FlashStack. Based upon the devices discovered, configuration template options are provided, allowing the user to select the most suitable FlashStack deployment configuration. Step 2 is configuration and requires a reduced set of simplified values be entered into Smart Config. These include global values like NTP, DNS, SMTP that apply to all devices, and unique values specific to UCS, Nexus, and MDS, including device names and IP addresses. As part of this phase, we also update firmware from an ISO library and select the operating system and associated customization scripts to be used for deployment on each compute node. Step 3 is initialization. Using the configuration completed in Step 2, Smart Config initializes all the devices that make up FlashStack. This phase also includes the ability to update device firmware. Step 4 is deployment. Workflows are used to configure each device and contain all the Cisco and Pure Storage best practices as documented in our joint Cisco validated designs. Smart Config has advanced workflows that could be customized via a GUI and exported for later reuse. There is also a set of basic workflows with fixed configurations that follow a CVD exactly and provide a read-only configuration view. Once we select deploy, a deployment log is displayed to help track configuration progress of each workflow. Any error messages that happen during the deployment will be included in the log, along with the ability to roll back and retry each workflow without having to perform a factory reset of all the devices. The overall progress of the deployment can be seen in the progress bar provided. Following a basic deployment using Smart Config can typically take about 45 minutes to complete in total. As you can see, this is a significant time saving compared to completing the process manually. Once the deployment's finalized, you can then go into UCS Manager and look at the configuration of each of the UCS blades, including the operating system being deployed. Thanks for watching the demo.
Oh, I'm sorry, that is incorrect. Kix was right on the money. But that means Michelle gets a square and you are our champion! Congratulations, Michelle. That's all the time we have, and we will see you next time on Silicon Valley Squares.